What's the P? Parts. And then there's an of that's not represented. Corresponding parts of congruent triangles are congruent. Okay, so what it's saying is if we find congruent triangles, right? So if I know this triangle is congruent to this triangle, which is everything we've been doing in this chapter, right? Proving triangle ABC congruent to triangle DEF. If I know that, then I can go one step further and say any two angles or any two segments in those two triangles will be congruent then. So the corresponding parts, the angle that matches up with the angle or the side that matches up with the side will be congruent, okay? CPCTC. So you will use CPCTC when you are trying to prove the parts, in other words, the angles or sides are congruent. Okay, if your last step of the proof is not triangle something congruent to triangle something, but instead angle congruent to angle or segment congruent to segment. So look for your last step. What are they asking you to prove? If that last step is not triangles congruent, it's probably CPCTC. Okay, so then that means the step before that, you're probably proving triangles are congruent, right? Because you got to prove the triangles are congruent before you can prove all the parts are congruent. Okay, which is that next thing. But first, you have to prove the triangles are congruent. Okay, so let's take a look at this. Again, when you start a proof, look at everything you know. So you've been given this information. So far, the proofs we've been doing, this has been triangles. But those are not triangles. Those are what? The green. Those are angles, okay? So you can start the proof the same way we've been starting it. Put in the given information that you know. AB congruent to AD. BC congruent to DC. And then your last step, BCA, will be congruent to angle DCA. So we know all of that already. We know our last step is whatever they want us to prove. We know our first steps are whatever they gave us. Okay? What's another really good thing to do right now? Mark what you know. So AB congruent to AD and BC congruent to CD. Okay, now look what they're asking you to prove. Don't mark it because we don't know it to be true yet. We're trying to prove that it's true. So it says BCA, that would be this angle, is congruent to DCA, okay? If they had said AC is a bisector, then we could say, yep, those are congruent, but they didn't, okay? So because they didn't really tell us anything about those angles, we have to go a more roundabout way. We have to prove the triangles are congruent, and then if the triangles are congruent, everything about them has to be congruent because of CPCTC. Anyone see a way that we can prove the triangles are congruent? Yeah, Ruby.
AC is congruent to CA, and that's reflexive.
So we can say AC is congruent to AC, or CA is fine, because it's reflexive.
And then that shows that the triangles are SSS, and then you can use CPC.
Okay, so we have our givens. We have that reflexive property, and using those three steps, now we can say triangle. Okay, now here's the biggest hiccup, in my opinion. Tell me which two triangles are congruent.
BCA and DCA.
Okay, if you say BCA, and then you tell me ACD, you're wrong, right? You have to match up the corresponding parts. So if it's BCA, then it has to be DCA. Side note, if they named the angles for you, it's probably pretty safe to just name the triangles the same order. Doesn't have to be, but it usually is. Those two triangles are congruent by SSS. So then because the triangles are congruent, everything about them has to be congruent. And the reason for that is CPCTC, because corresponding parts of two congruent triangles will always be congruent to each other. Okay, so do you see how we really aren't doing a whole lot new? This is the only new step. The rest of it you've done a million times now. Maybe not a million, just under that. Does that make sense? Okay, I would like you to try number 2 and number 5 right now. Okay, let's work it out. I feel like a broken record, but it's probably partially because I have 2 classes and you're just one of those 2 classes. And I'm sorry if you feel like I'm a broken record saying the same thing over and over and over again. But that's kind of how these proofs go. Like, there comes to be this pattern of like, oh, when I see this, it's always this, right? When you see parallel lines, it's always what? AIA or CA, right? Look for the types of angles that parallel lines create. So in this one, you should be looking for, if they're telling me lines are parallel, do I see alternate interiors or corresponding somewhere? Okay, so look for that when they give you that as your given. So let's write that down first. PS is parallel to QR because it's been given. Okay, I'm gonna write the second given at the same time just for the sake of not forgetting that I wrote it down. Second thing, your vertex is always which letter in the 3 letters? The middle one, okay? So my vertex right now is at P and R. Angle QPS, from Q to P to S, that's this angle, okay? SRQ, that's that angle. So mark them. We know those are congruent. Also given. Okay, so knowing all that information, tell me what you did next. Okay, QS is congruent to QS. Did you know that doesn't have to be your 3rd step? There is another option, but QS congruent to QS is a great 3rd step. Mark it congruent. Side note, I think forgetting to mark things as you go, so like as you say something that wasn't in the given, if you don't mark it, you often don't see where you went from there. So make sure that as you say something new, you mark something new, okay? So QS congruent to QS, that's reflexive. Simon, what was the other thing you said? PSQ, angle PSQ is congruent to angle RQ, what'd you say? RQS. Yeah. Okay, and why are those congruent? AIA. Okay, so you have all this information right now. Hopefully, with all that information, if you're looking at your picture, you see something. What do you see?
Angle side angle.
It's not angle side angle. It's angle side angle would be if they told us these 2 sides are congruent. Do we know those 2 sides are congruent?
No.
Mm-mm. AAS. It's angle, non-included side. Okay? So this is going to be the triangles are congruent. And again, you got to name the triangles the right way. So if I'm going to name it triangle QP, that's not a P, that's an R, QPS. Okay? If I say QPS, then what do I have to say for my other one? SRQ. Triangle SRQ. So name them in the same order. And that is by angle, side. Okay, so how do I prove PQ is congruent to RS? CPCTC, because the corresponding parts are congruent, the entire triangles are congruent, therefore, because the triangles are congruent, the corresponding parts are congruent, so those are congruent segments. Okay? All right, go down to number 5. They told us that BC is parallel to EF. What should that point you to? Why would they tell you lines are parallel? Probably AIA, okay? Could be CA, but it's probably AIA. But mark it, parallel lines, okay? Not congruent, parallel. Second thing says D is the midpoint Now be careful because they tell you specifically what it is the midpoint of. Don't go another route there. D is the midpoint of BF. The last thing we're trying to prove is ED is congruent to CD. So when you look at that and you see, oh, those are segments. If we're trying to prove segments congruent, what is likely the last step? CPCTC. But in order to use CPCTC, we first have to prove what? That the triangles are congruent. Okay, so we got to find a way to prove these two triangles congruent, knowing what we know. Those first two steps are given. Where did you go from there? And why is that? Yeah, so notice it said it's the midpoint of BF, not the midpoint of EC. So don't say ED is congruent to DC, okay? Say BD is congruent to DF by definition of a midpoint. Remember what I said, broken record. If the word is in the given, the definition of that word is probably in your proof, okay? Okay, next thing. What else can we say? Use your given information. What'd you do, Haley?
I did angle DEF is congruent to DCB because of AIA.
Angle DEF and DCB.
Yeah.
Angle DEF is congruent to angle DCB because those are alternate interior angles. The only way you know that is because they told you the lines were parallel. If the lines are parallel, then you're gonna get AIA or CA. In this case, those are alternate interior angles, okay? Ryan?
Would angle C congruent to angle E?
Totally. No, you can absolutely do that. You can say angle C congruent to angle E. As long as there's just one angle there, you may use one letter. Okay, so if you like that better, by all means, E congruent to C. What else did you use? You got two options here for your next step. Arthur, what'd you do?
I didn't get that one.
Didn't do it? Are you doing it with me now? Do you see it? Taylor, do you see it?
I actually got stuck on I was kind of lost, so I did extra definition of midpoint. I don't think that's correct though.
Yeah, definition of midpoint would just be the one set of sides.
Yeah.
You have two options here. Connor, what'd you get?
I did angle EDF is congruent to angle CDB.
Okay.
The vertical angles.
Okay, so if you want to use vertical angles, you would say angle EDF is congruent to angle BDC because those are vertical angles. If you chose not to do vertical angles, then what was your step right here? AIA. Okay, so you could have also said angle B is congruent to angle F because of AIA. Okay, so either do the purple or do the blue. You don't need both of them. What's step number 6 then? The triangles, yeah. So triangle, if I say EDF, then what triangle is that congruent to? EDF.
Oh,
CDB. Yep, in the same order, right? In the corresponding order. By what? Tell me the right one. Tell me the right one. AAS, yes. It's not the included side, so that's AAS. So then why are these two segments congruent? CPCTC. How's that? Pretty good? Okay. All right, so if you want to see another, here we go. If you want to work on the homework, that's fine. So number 1, it says X is the midpoint of two segments, WY and VZ, okay? That's your given. Okay, now that should lead you to something. Definition of midpoint. How? What can you say that is by the definition of midpoint?
Can I say XY? Wait, no, WX
Uh-huh. WX is congruent to YX by definition of a midpoint. Okay. Can you tell me something else that we know?
Since it's like vertical angles,
Okay.
can I say like WXB is like
Congruent
yeah,
to what?
ZXY.
Mm-hmm. Okay, so that's vertical angles. What else can you say? Look at your given one more time.
Oh, can I say? I can say B is like BX
Mm-hmm.
congruent to ZX.
Uh-huh. And why is that?
Definition.
Yes. Okay. What can you say next?
Triangle X W B is congruent to X Y Z because is it S?
Mm-hmm. I'm so proud of you right now, Simon. This is fantastic. What's your last step? I sound like a mother, huh? I'm so proud of you.
X W B is congruent to X Y Z because it's CP.
Yes. CPCTC. Good job. Killed it.
Be quiet, bro.
I'm not me? Messing with him?
Yeah.
No. Don't be mean. He did a great job. I'm just very proud of him. Anybody want to see another one? Number 4? Are you good? Number 4? You want to try it? Let's do it. Come on. What's your first step? Okay, so JM bisects angle KJL. I'm going to separate the given. So JMK congruent to angle JML. Which of those two can you actually mark on your triangles right now? 1 or 2? The second one. Okay, so both are given. But you can actually mark JMK. So you start at J through M through K. So that's this guy. And then JML is that guy. What's number 3 going to be? Lovely. JM congruent to JM. And why is that? It's the reflexive property, same line. Okay. There's one more thing that you know about those two triangles. What is it? Something that your given should be pointing you to. What's your given information? It bisects, okay. Okay, so if it bisects this, then what is congruent?
JL and JK.
It's not bisecting the segment. It's bisecting an angle, right? So if it's bisecting an angle, Michael. Oh, yeah, leave your phone. If it's bisecting an angle, then you should be saying angles are congruent, right? Because it's cutting an angle into 2 equal parts. If it bisects a segment, Michael. A child. So if we are saying an angle gets bisected, okay, you are going to say this angle congruent to that angle, right? So angle KJM is congruent to angle LJM, okay? What's the reason for that?
Definition of bisector.
Yep, definition of a bisector. Okay, now what? Step 5.
JLM.
What goes in front of JLM?
Triangle.
Triangle. Okay, so the triangle, so if you say JLM is congruent to, then what triangle?
JMK.
If you say JLM, what does that match up with on the other one?
Oh, JK.
JKM. Okay, and why is that?
ASA.
ASA, angle included side angle with angle included side angle. So that's ASA. Okay, and then what's your last step?
JK is congruent to JM.
And why is that?
CPCTC.
CPCTC, you killed it. Good job.